Friends, it's Dr. Ashok here. The objectives of this session is at the end of this session, you should be able to explain the importance of sustainable agriculture, identify the integrated farming systems, list the modern methods of irrigation, examine the agronomic interventions for enhancing the fertilizer use efficiency. Dear friends, until now we discussed the fundamental concepts of agriculture such as soil, crop, and crop production. I will be introducing you to some of the advanced concepts of agriculture. As we know, the cultivation and farming of plant crops is a process that consumes more time, requires labor intensive tasks, and the output is uncertain because of the unpredictable disturbances in the agents that support plant growth. Moreover, until recently, the farmers used to concentrate only on crop production. This was subjected to high cases of uncertainty in income and employment to the farmers. Hence, it became unnecessary to develop suitable approach for income from a farm. So the integrated farming system was formulated that not only provides the farmers with perennial income but also sustain the agricultural process as such. Sustainable agriculture can be defined as a type of farming system that is capable of maintaining the productivity of a farm throughout a year. It emphasizes on the conservation of natural resources while being socially supportive, commercially competitive, and environmentally sound. The USDA defines sustainable agriculture as an integrated system of plant and animal production practices having a site specific application that will, over the long term, satisfy human food and fiber needs, enhance environmental quality, and the natural resource based upon which the agricultural economy depends, make the most efficient use of non renewable resources and on farm resources, integrate where appropriate natural biological cycles and controls, sustain the economic viability of farm operations, enhance the quality of life for farmers and society as a whole. Some advantages of sustainable agriculture are low production cost, reduction in overall risk of the farmer, pollution of water is avoided, very little or no pesticide residue is ensured, ensures both short and long term profitability. One prominent disadvantage of sustainable agriculture is that it uses least quantum of inputs. This results in comparatively less output or less yield. Major components of a sustainable agriculture system are soil and water conservation to prevent degradation of soil productivity, efficient use of limited irrigation water without leading to problems of soil salinity, alkalinity, and high groundwater table, crop rotations that mitigate weed, disease, and insect problems, increase soil productivity, and minimize soil erosion, integrated nutrient management that reduces the need for chemical fertilizers, improves the soil health, and minimize environmental pollution by conjunctive use of organics, inorganics, and biofertilizers. Next is the integrated pest management, which reduces the need for agrochemicals by crop rotation, weather monitoring, use of resistant cultivator, planting time, and biological pest control. Management system to control weed by preventive measures, tillage, timely intercultivation, and crop rotation to improve plant health. Let's move to next important concept, the integrated farming system known as the IFS. Integration farming system relates to grouping of two or more appropriate enterprises like crop, dairy, piggery, fishery, poultry, beekeeping, etc. for each farm according to the availability of resources to sustain and satisfy the necessities of the farm. Integration farming system can be defined as a farming system is a collection of distinct functional units such as crop, livestock, processing, investments, and marketing. Investment and marketing activities which interact because of the joint use of inputs they receive from the environment, which have the common objective of satisfying the farmers, that is, the decision makers' aims. The definition of the borders of the options depends on circumstances. Often it includes not only the farm, that is the economic enterprise, but also the household, that is the farm household system. Some of the possible enterprises of integrated farming system are wetland based farming system, which consists of possibilities such as crop plus fish plus poultry or pigeon, crop plus fish plus mushroom, garden land based farming system, which consists of crop plus dairy plus biogas, crop plus dairy plus biogas plus sericulture, crop plus dairy plus biogas plus mushroom plus silviculture. Dry land based farming system consists of crop plus goat plus agroforestry, crop plus goat plus agroforestry plus horticulture. Some prominent benefits of IFS are higher productivity, profitability, sustainability, balance to food, recycling reduces pollution, money round the year, employment generation, increase input efficiency, standard of living of the farmer is increased, better utilization of land, labor, time, and resources. Before going through advanced methods of irrigation, let's know what is irrigation. Irrigation is defined as the artificial application of water to the soil for the purposes of crop production in supplement to rainfall and groundwater contribution. Some prominent irrigation methods are surface, subsurface, pressurized irrigation. Now, let's know about each one of them in detail. Surface irrigation methods are oldest, that is 4000 years back, and most common method. 90% of world's total irrigated area is under this method. In USA also, 66% is by surface irrigation. This method is most suitable for low to moderate infiltration rates and leveled lands and having less than 2 to 3% slope. It is labor intensive. Surface is grouped as border, check, basin, and furrow irrigations. In case of border irrigation, the land is divided into number of long parallel strips called borders. These borders are separated by low ridges. The border strip has a uniform gentle slope in the direction of irrigation. Each strip is irrigated independently by turning the water in the upper end. The water spreads and flows down the strip in a sheet confined by the border ridges. Check basin irrigation is the most common surface irrigation method. Here, the field is divided into smaller unit areas so that each has nearly level surface. Bunds or ridges are constructed around the area, forming basins within which the irrigation water can be controlled. The water applied to a desired depth can be retained until it infiltrates into the soil. The soil of the basin varies from 10 m2 to 25 m2, depending upon soil type, topography, stream, and crop. Furrow irrigation is used for row crops. The furrows are formed between crop rows. The dimension of furrows depends on the crop grown, equipment used, and soil type. Water is supplied by small running streams in furrows between the crop rows. Water infiltrates into soil and spreads laterally to wet the area between the furrows. In heavy soils, furrows can be used to dispose the excess water. So, let us move to second type of irrigation method, subsurface irrigation. In subsurface irrigation, water is applied beneath the ground by creating and maintaining an artificial water table at some depth, usually 30 to 75 centimeters below the ground surface. Moisture moves, open ditches are preferred because they are relatively cheaper and suitable to all types of soil. Irrigation water should be of good quality to prevent soil salinity. Advantages of surface irrigation methods are minimum water requirement for raising crops, minimum evaporation and deep percolation losses, no wastage of land, no interference to movement of farm machinery. Cultivation operations can be carried out without concern for the irrigation period. Disadvantages of surface irrigation method. It requires a special combination of natural conditions. There is a danger of water logging, possibility of choking of the pipes lay underground, high cost. After having known basic irrigation methods, now let's know about the modern irrigation methods. Pressurized or modern irrigation. Some modern irrigation methods are drip irrigation system, sprinkler irrigation system. Let's begin with the drip irrigation system. Drip irrigation system or trickle irrigation is one of the latest and modern methods of irrigation. It is suitable for water scarcity and salt affected soils. Water is supplied in the root zone of the crop. Standard water quality test needed for design and operation of drip irrigation system. Drip components are: a drip irrigation system consists of a pump or overhead tank, main line, submains, laterals, and emitters. The main line delivers water to the submains and submains into the laterals. The emitters, which are attached to the laterals, distribute water for irrigation. The mains, submains are usually made of PVC, that is polyvinyl chloride, pipes and laterals of LDPDA tubes. The elements are also of a PVC material. The other components include pressure regulator, filters, valves, water meter, fertilizer application devices, etc. The advantages of drip irrigation are high water use efficiency, that is up to 95% compared to less than 50% in surface as such. Flexibility of wetted area, versatile selection of emitters type, discharge rate position, economy in weed control, low interference with cultivation, day and night irrigation, prevention of leaf wetting, energy saving, salinity control, irrigation at a variable topographic conditions. Now, limitations of drip irrigation are high investments, high level of knowledge for optimal and economical operation, susceptibility to mechanical damage, large number of emitters, long application time, high levels of filtration and other controls, maintenance. Let's move to sprinkler irrigation system. Sprinkler irrigation system is another important modern irrigation technique followed all over the globe. The sprinkler, that is the overhead or pressure irrigation system, conveys water to the field through pipes. aluminum or PVC under pressure with a system of nozzles. This system is designed to distribute the required depth of water uniformly, which is not possible in surface irrigation. Water is applied at a rate less than the infiltration rate of the soil. Hence, the runoff from irrigation is avoided. On the basis of arrangement for spraying irrigation water, they are classified as rotating head or revolving sprinkler system and perforated pipe system. Based on the probability, sprinkler systems are classified as portable system, semi-permanent system, solid set system, and permanent system. Advantages of sprinkler irrigation system are suitable for undulating topography, that is slopy lands, water saving, that is 35 to 40 degree compared to surface irrigation methods. Fertilizers and other chemicals can be applied through irrigation water. Saving in fertilizers, even distribution and avoids wastage. Reduces erosion, suitable for coarse textured soils, that is sandy soils. Frost control, protect crops against frost and high temperature. Drainage problems eliminated. Saving in land. Limitations of sprinkler irrigation are high initial cost, efficiency affected by wind, higher evaporation losses in spraying water, not suitable for tall crops like sugarcane, not suitable for heavy clay soils, poor quality water cannot be used, sensitivity of crop to saline water and clogging of nozzles. Next is the drainage. Drainage is the artificial removal of water which in excess of the quantity required for the crop. Drainage includes removal of excess water from both the surface and subsurface of the crop's root zone. Irrigation and drainage go together and are not mutually exclusive. Irrigation aims at supplying optimum quantities of water throughout the crop period, whereas drainage aims at removing excess quantity of water in short time. Often, both may be required together to assure sustained and high level production of crop. Role of drainage in crop production are draining the land provides conditions favorable for crop production. The greatest benefit of drainage relates to aeration. Good drainage facilitates the ready diffusion of oxygen to the root zone and escape of carbon dioxide from the root zone into the atmosphere. Several harmful gases also escape from the root zone into the atmosphere. The activity of aerobic organisms, which influence the availability of nutrients such as nitrogen and sulfur to plants, depends on soil aeration, and hence drainage improves aerobic organisms. Toxicity in acid soils due to excess iron and manganese is decreased by drainage due to presence of oxygen in the root zone. Drainage permits roots to grow deeper and spread wider, thereby increasing the volume of soil from which nutrients can be extracted. The removal of excess water helps in drying of the soil quickly, and optimum soil temperature permits timeliness of field operations. The provision of a good drainage system permits the removal of excess salts in the soil or irrigation water and prevents their buildup in the upper soil layers. Let's move to the next concept: agronomic interventions for enhancing few agronomic measures to improve the fertilizer use efficiency are using best fertilizer source, using adequate rate of diagnostic techniques, usage of balanced fertilization, integrated nutrient management, utilization of residual nutrients. Let's know about each one of them in detail. Using best fertilizer resource helps identification of best source of fertilizer is a prerequisite for better crop production. Source of fertilizer depends on crop and variety, climatic and soil condition, availability of fertilizer, etc. Nitrogen, ammonia, calcium or nitrate, phosphorus, water soluble or citrate soluble, potassium, murate of potash, sulfur, sulfate or elemental S, multi-nutrient fertilizers, MAP, DAP, SSP, nitrophosphates, multi-nutrient mixtures, several combinations of NPK, fortified fertilizers, neem-coated urea, zinc-coated urea, boronated SSP, NPKs mix as such. Using adequate rate of diagnostic techniques, the fertilizer recommendation must be in adequate quantity so as to meet the demand of crop at any point of growth. The fertilizer supply is made by diagnosing its requirement by any of the following method. State recommended generalized fertilizer dose or blanket recommendation. Soil test based fertilizer recommendations. Soil test crop response based recommendations. Plant analysis for diagnosing nutrient deficiencies. Chlorophyll meter and leaf color charts, etc. Balanced fertilization includes adequate supply of all essential nutrients, proper method of application, right time of application, and nutrient interrelationships. Adequate supply of all essential nutrients due to more concentration and application on primary nutrients, that is the NPK, soils develop deficiency symptoms for secondary and micronutrients. Hence, ignored elements must be added with the NPK, maybe in minor quantity, to get higher yields in crops. Experimental results show that about 20 to 25 kg of micronutrient application or 2 foliar sprays increases the yield of crops up to 20%. Next is proper method. N and K are be applied as broadcasting and band placement. Water soluble P fertilizers are preferred to apply as band placement in neutral and alkaline soils. Citrate soluble P fertilizers are applied as broadcast method in acidic soils. Sulfate forms of S fertilizers are applied as broadcasting or band placement. Whereas elemental S and pyrite are applied as broadcasting method. Micronutrients are applied in minor quantity as foliar sprays and water-soluble fertilizers are applied in fertigation. Right time according to physiology of crop. Upland crops 2 splits, seeding 3 to 5 weeks after first close. Flooded rice 3 splits, transplanting 3 and 6 weeks after first dose. Next is nutrient interrelationships. Antagonistic nature of fertilizer is to be considered while applying into the soil. Some of the fertilizer application in excess cause loss of yield and quality of crops. Example, application of excessive 120 kg of potash per hectare HA1 created an imbalance and reduced the seed and oil yields in soybean compared to 80 kg PHA1. In case of integrated nutrient management, organic manures, crop residues, green manures, biofertilizers, etc., are to be blended in right manner along with inorganic fertilizers to meet the crop demand. All the possible and available organic sources are to be utilized efficiently to reduce the usage of inorganic fertilizers. Some of the strategies to utilize the crop residues in efficient manner are knowledge on climatic conditions and carryover effects of residues, blending rightly on cereal legumine rotations, mixing shallow deep rooted crop rotations. Now, intercultivation. Intercultivation involves the cultivation practices taken up after sowing a crop. It is otherwise called as a After operation, there are two important activities that need to be performed during cultivation: thinning and gap filling, weeding and hoeing. Let's know more about each one of them. Thinning and gap filling. The objective of thinning and gap filling processes is to maintain optimum plant population. Thinning is the removal of excess plants, leaving healthy seedlings. Gap filling is done to fill the gaps by sowing of seeds or transplanting of seedlings in gap where early sown seed had not germinated. It is a simultaneous process. Normally, these are practiced a week after sowing to a maximum of 15 days. In dryland agriculture, gap filling is done for seeds are disabled after 7 days of sowing. Thinning is done after gap filling. In order to avoid drought, it is a management strategy to remove a portion of plant population to mitigate stress is referred to as mid-season correction. Weeding and hoeing. Weeding is removal of unwanted plants. Weeding and hoeing is a simultaneous operation. Hoeing is distributing the topsoil by small hand tools and helps in aerating the soil. Earthing up is a dislocation of soil from one side of a ridge and to be placed near the cropped side. It is carried out in wide spaced and deep rooted crops. It is done around 6 to 8 weeks after sowing, planting in sugarcane, tobacco, banana, etc. Other intercultivation practices involve harrowing, roguing, topping, propping, detrashing. Harrowing. Harrowing is a stirring or scraping the surface soil in inter and intra-row spacing of the crop using tools or implements. Roguing. Roguing is removal of plants of a variety admixed with other variety of same crop. Example, in IR50 rice field, the other rice varieties are rogue. It is practiced in seed production to maintain purity. Next is topping. Topping involves removal of terminal buds. It is done to stimulate axillary growth, practiced in cotton and tobacco. Propping. Propping is provision of support to the crop is called propping. Practiced in sugarcane commonly, it is done to prevent lodging of the crop cane stalks from adjacent rows or brought together and tied with their own trash and old leaves. Detrashing. Detrashing is the removing of older leaves from the sugarcane crop. Desuckering. Desuckering is removal of axillary buds and branches which are considered as non-essential for crop production. The plants which remove plant nutrients considerably are called suckers. Example, tobacco. To sum up the whole thing, it's a conclusion. In this session, we discussed about the importance of sustainable agriculture. We identified the integrated farming systems and listed the modern methods of irrigation. Finally, we examined the agronomic interventions for enhancing the fertilizer use efficiency. The integrated farming system approach introduces a change in the farming techniques from maximum production in the cropping pattern and takes care of optimal utilization of resources. A judicious mix of agricultural enterprises like dairy, poultry, piggery, fishery, sericulture, etc., suited to the given agroclimatic conditions and socio-economic status of the farmers would bring prosperity in the farming. Sustainable agriculture means an integrated system of plant and animal production practices that reduces the overall risk of the farmer and pollution of water is avoided. By going through this session, we got to know that the modern irrigation methods help in applying efficient techniques in farming in order to reduce the wastage and unnecessary costs. Thank you for hearing.